Okay, here we are for video number 3. This one will be a quick one because this is the one that you wish everybody, all the compounds did. So this one is our last little piece on binary compound naming, and then we'll get into the polyatomics here in a second. So this one is about molecular compounds. So again, it's a little bit of a different setup on these ones. So with these, this is still binary compounds, so still 2 and only 2 elements are present. Again, not number of atoms, just the number of elements that are present. But in this particular one, we're going to differentiate between binary ionic compounds, which is what we did in the last video, versus binary molecular compounds, which is what this one is about. So when we're talking about ionic compounds like the last one, these were all metal, non-metal. Oh, and there we go. It's hard for me to write and talk at the same time. So ionic compounds are metal and non-metal, and this is the one where they've got that positive and the negative side to it. And then from the first video, we talked about how molecular compounds were formed. So these are non-metal, and non-metal. So usually 2 different non-metals bonding together. So when you see a compound and it has a formula where the first thing that's in it is a non-metal, chances are very good that it's one of these molecular compounds. So a really good example of a molecular compound that you're familiar with is this one. I use this example all the time, CO2. You know this as carbon dioxide, right? This is a compound that you have seen or heard of in your daily life. Carbon is a non-metal. Oxygen is also a non-metal. This is a molecular compound. It's formed from sharing of electrons inside that particular compound. Oops, I got a cough here for a second. Ooh, hold on. Didn't want to blow out your ears there. Sorry about that. Didn't want to hurt your ears. So with this, these particular ones, these do not balance charges, and this is kind of interesting when we're writing the formulas. So no balancing charges. So if you're taking a look at the periodic table and say, oh yeah, there's a +1 and a -1 or something like that, that is not how we write these formulas. It's actually way simpler. So make sure that you're aware of this. We're only doing balancing charges with ionic compounds. Molecular compounds do some really funky stuff. And I remember from the other day, we talked about the law of multiple proportions. And the law of multiple proportions was literally directly related to molecular compounds like this, where there was more than one possibility for a compound that had the same elements in it. And so here's another example of C and O. This top one is carbon dioxide. This bottom one is carbon monoxide. So maybe that's starting to give you some hints into some of the naming patterns that are done on this one. So here's what's nice about this one. Writing names. Okay, names super easy. The second element changes that same ending like we've done before. So you're still going to end it in "ide." So it was carbon dioxide, carbon monoxide, right? That was the same. Notice how the first element, carbon dioxide, carbon monoxide, we don't change the name of that at all. But we did change something about the oxygen. We didn't just call it carbon oxide, right? We call it carbon dioxide or carbon monoxide. So these are the ones that have the numeric prefixes. Numeric prefixes, Refixes. So we use numeric prefixes to tell us the formula. And we literally have to state the formula in the name because of this law of multiple proportions. There's so many different ways that they can combine together. We have to be really specific about what we call it because there's a lot of different variations that are possible. So the numeric prefixes are really pretty straightforward. You probably remember a lot of them. So mono is 1, then there's tri. So 1, 2, and 3. 4 is a little bit tricky one. Mono, di, tri. Sorry if that looks a little bit funky. That's the T-R-I. Okay. The one for number 4 is a little bit trickier. Sometimes students have a problem with that. T-E-T-R-A. Tetra, like the game Tetris, means 4. It's Greek. So there you go. Mono, di, tri, tetras. That's 1, 2, 3, and 4. 5, just like in geometry, is penta. Or penta. 6 is hex or hexa, depending on what it's with. So that's 6. 7 is hept. 8 is oct, O-C-T-A. It's supposed to be a C. All right, octa. 9 is N-O-N-A, and 10 would be deca. Again, these are pretty straightforward in terms of ones that you've used before. OCTA, there we go. So these are the numeric prefixes that we are using for these. So let me give you a couple of other examples. Again, with using these, write them down on a Post-it note so you've got them someplace easy for you to use. But the numeric prefixes is a pretty easy thing to kind of take care of. All right, so let me give you some examples of what this would look like. Need my pen back. We would have NO, N2O, and NO2, and N2O5. Yes, these are all actual compounds that exist. Law of multiple proportions. Nitrogen and oxygen specifically is really bad. Okay, one nitrogen and one oxygen, and this will show us an important rule about using one of our prefixes. So this is called nitrogen monoxide, MONOXIDE. So monoxide, right? So an important thing to notice about this, again, this is one of these little exceptions to our prefixes rule. The mono prefix is only used on the second element. It's never used on the first element. So think about our carbon monoxide, right? It wasn't monocarbon monoxide, it was just carbon monoxide. So mono is only used on the second element. It's never used on the first element. So again, that's one of our only really exceptions to the prefixes in terms of how they work. Okay, our second one down here, 2 nitrogens, 1 oxygen. So we would name it as dinitrogen. We have 1 oxygen, monoxide. Again, super systematic, super easy how these work. Dinitrogen monoxide, I can look at that name and I can tell you exactly what the formula is, right? 2 nitrogens, 1 oxygen. 2 nitrogens, 1 oxygen. This one's different. So this one is nitrogen. Again, we don't put the mono on there because it's the first element, so we don't do it there. And then the second one, we've got 2 oxygens, so we call it dioxide. Nitrogen dioxide versus dinitrogen monoxide. Again, they have different formulas to it, and they do both exist. And then this last one, you're going to have 2 different numeric prefixes, so give it a sec, see if you can figure out what it would be. You're going to have a numeric prefix on each one. Got it? Dinitrogen pentoxide. We don't say pentaoxide. If the second element begins with a vowel, then we don't need the A. If the second element begins with a consonant, then we need the A. So like you do pentafluoride, but you just do pentoxide. That's why sometimes it's pent or penta. Same thing with tet and tetra and all those kinds of ones. So there you go. So naming these molecular compounds, very straightforward. Again, numeric naming system. And when we use these, again, these are for molecular compounds only, where the first one is a nonmetal and the second one is a nonmetal. This is the only time that you use this numeric naming system like this, is with molecular compounds. Ending is still IDE on the second word. And then the only other exceptions, we do not use mono on the first word. So there you go, molecular compound naming. I know you wish they were all that easy, but unfortunately they're not. So there you go, molecular compounds. Hope you enjoyed it. See you in polyatomics coming next.